The topic of this presentation focuses on the neural markers of conflict processing. Particularly, the midfrontal theta power has been consistently reported to increase for incongruent trials in comparison to congruent ones. And this activity was estimated to be from the pre-supplementary model ARIA, in line with previous fMRI studies investigating that issue. So in this study, we used simultaneous EEG and fMRI to couple midfrontal theta with both signal in order to verify its source. And we hypothesized that the pre-SMA is the source of theta. However, interestingly, previous studies addressing this issue in a resting state of working memory task using simultaneous EEG and fMRI found that theta showed only negative relationship to both signal. And this negative relationship can be observed in brain regions that typically show task-related deactivations. So would the same hold true for midfrontal theta involved in conflict task? To address that, we did simultaneous EEG and fMRI study with 35 participants with a number of factors. Most importantly, the incongruency effect was observed. The EEG results revealed, traditional EEG results revealed increased amplitude in theta band prior to the response. The fMRI analysis revealed several brain regions within the medial frontal cortex. Some of them, 6 of them showed sensitivity to conflict condition, including pre-SMA, and brain regions that deactivates, like area 9 and 10. So to couple these two signals, we use a linear mixed effect model where all those brain regions were treated as a predictor of theta activity. And against our hypothesis, the pre-response conflict theta showed only negative relationship in midline area 9. With the region that showed conflict sensitive deactivation. So just to verify the model, we also checked error-related theta activity as the post-response window, where error shows higher theta values than the correct trials. And this activity showed positive correlations to anterior cingulate cortex, in line with the region being sensitive for error processing. So just to final analysis was to conduct multiple linear model for every pixel in the time frequency plots. And this analysis confirmed that the pre-response conflict theta shows only negative relationship with midline area 9, whereas post-response error-related theta shows positive relationship to anterior cingulate cortex. Therefore, our study shows that first, conflict and error theta represents fundamentally different processes, where the post-response error theta is generated in ACC and signals according to literature, in line with the literature signals the need for adaptation or surprise, whereas the pre-response conflict-sensitive theta is generated in midline area 9. And since this region is showing deactivation, it seems that theta reflects active inhibition of task-irrelevant, probably metacognitive processes such as mind wandering that are necessary for goal-directed behavior. If you're interested or would like to discuss, see my poster in prefrontal cortex session. Thank you for the attention, and this work was supported by National Science Center.